Hey everyone, Lucky Arduino here. Today I will be talking about the Super Starter Kit Uno R3 project. This is a kit made by Elegoo and it is one of the best kits I have ever worked with. It is about $45 on Amazon and I would recommend you get it if you haven't already gotten it to make some really cool projects. And if you have already got it, then today what I'll be doing is explaining all the parts for an introduction so that you can start building some cool projects. And if you want to check out my other videos, I show some basic and also some hard projects on this channel. So let's open it up. And as you can see, I have removed all of the parts just for simplicity because everything in here gets super crowded and it's not worth it keeping all of it in one case for this video. And all I have in here are just some wires for extra storage. Let's move that off to the side. So our first part is the most important, the Elegoo circuit board. Basically what this has, it's all digital ports which provide output. So like if you wanted to light up an LED, say, you would use these digital ports to control when you wanted to turn it on and when you wanted to turn it off. And then you turn it over to the other side. Here you have analog ports, which are input ports. If you wanted to read how much voltage your LED was getting, you could use these ports and determine that. And then you have 5 volts and ground over here on this side, and some other ports that are really helpful for different projects. And basically, what these ports do is they provide a steady source of output, right? Instead of varying outputs like these ports here, these digital ports, you can have one output, which is 5 volts and one ground, right? And this is really helpful for a project that doesn't require too much variability. All right. And this is the basis for all your projects. You need this for everything, right? And then you can see you have 2 different ports here, and these are both used for different things. All right, let me set this down for a second. So what this first square port is used for is this connector, USB. And this side connects into the board, and this USB side would connect into 2 places. The first option is your laptop where you're writing your code, and this would help upload your code into the circuit board, and then the circuit board would send it to all of your components. And basically that is the more convenient option for me, so that is the way I'll be using it in all of my videos. And if I wanted to detach it, if I wanted to detach the circuit board from my laptop, this is where this wire would become useful, right? This wire has a circular connector to plug in here, and this side plugs into a 9-volt battery, right? And what this does is provide power without having to lug your computer around, right? And this is convenient because if you wanted to make a really practical project that didn't require your laptop, you could just use this battery to supply power, and before you started the project, you would upload the code onto your circuit board, right? And this is really helpful. And you can also have a third component attached to that, which is your circular part would go in here, and then from your other wire, you would have a USB goes in right here, right? And so what this would do is you would have a battery attached to this microcontroller, and this microcontroller would be attached to the original circuit board. And the advantage that this microcontroller has is a switch. So you can turn your battery voltage on or off. And this allows you to create binary situations where you have a 0 for off and a 1 for on, right? And you can deliver power to your circuit based on that, right? And so that's the basics of the Elegoo circuit board, and that's mostly how we'll be using it on this channel. All right, so the next component is a breadboard. All right, and the breadboards used in this Uno R3 kit are super useful because you don't have to solder anything. All right, every column is connected. If we get a closer look, every column of holes is connected, and this is not a given in different breadboards where you have to actually solder your parts and attach them to the board itself, right? And that can be really tedious and really annoying, and that's what's great about this Arduino thing, Arduino project, right? And then you have the bigger breadboard here. This is a sneak peek, but we'll be focusing on just these rails down here. All right, so these rails are negative and positive. So negative always goes to ground, right? And so if we look at the bottom, this whole negative rail is connected, right? So if you connect just one of these ports to the ground on your circuit board, all of these will be connected to ground. And for the positive, you can connect voltage or power, right? And this would be usually connected to 5 volts, right? And again, that would be connected across this whole rail. And then these ones in the middle act like the other breadboard I just showed you, the tinier version, where all of them are connected vertically, right? And so this can make for some really cool projects, which I will show you in the next video. And then some of those parts that you saw just now include the LED and the resistor. So let's go over the LED first. So here you have a blue LED, and you have a long side and a short side. Now, what's different about these sides? Right, so the long side will always connect to a resistor, right? And so here you have a resistor, and basically what this does is prevents pure voltage from going into the LED. And if it does get pure voltage, if the LED does get pure voltage, then the LED will end up blowing up, which is not something that we want, right? So this limits the current. And the shorter side of this LED, which is on this side, goes to ground, right? And so that is how you connect your LED. If you connect it backwards, nothing will happen. If you forget to put in your resistor, it will blow up. If you forget to connect one of your wires, again, nothing will happen. So that's one of the most basic projects you can make as part of the Arduino kit, and I will be showing that in a later video. All right, now let's go over some wires. So we have two main types of wire. Our first wire is a regular wire with two connections, all right? Two metal parts that connect to two different ports, right? And this just carries the voltage over to another spot, and it helps connect all of your circuits together. And then you have this one. This is a female to male wire. As you can see, this side has no metal part on it, and this side does. This is helpful for extensions and for connecting the parts that don't connect to your breadboard. Their ports are a little bit too big or something like that, and so you can just connect them directly to this extender, and they will work outside of your breadboard. And that's really useful for parts like the joystick, which I will show later. And so basically, these wires form the basis of all of your connections. All of your connections have to be made through wires or short extenders, which don't come with this kit, unfortunately. So your projects look very complicated, but in reality, they are not so complicated. And one more thing, as you can see, these wires do have different colors, right? If we open up the kit again, you'll see all this mess of wires, right? And so these wires are color-coded by size, right? So red wires will have a different length than green wires, and so on. All right, let's move on to our next part. All right, so our next parts will be some miscellaneous parts that you can use to make your projects much better and much more diverse. So our first part is a distance sensor. Now you can connect this directly into your breadboard, or once again, have your female to male connector go right in. There you go. And now it's connected, and you can connect this side to your breadboard, the side with the metal part, right? And sorry for the focus. The focus is a little bit wonky. And basically what this does is it allows you to sense how far something is from you. So like, let's say I wanted to sense how far the camera is, right? So I would connect this to my breadboard, and it would give me an input value, and I would have to convert that into inches or centimeters or whatever suits my needs. And when I do connect this to the Arduino, there is an option to convert it into a specific measurement by itself, right? So that's already written for you, which is pretty cool. All right, our next part is a joystick. I talked about this earlier, but basically you have options. You can move this joystick anywhere you want, and you also have a button, right? And so basically you have the ports, which you can attach again with the female to male connector right there, and you have the other part which can go anywhere. Yep, and this is really useful if you've done like gaming. You know that joysticks are really useful in gaming on controllers. All right, our next set of parts are displays, right? So this specific type of display is a number display where it displays, this one displays numbers from 0 to 9, and it has a decimal point if you ever need that. And then this one is bigger, right? So this one can display numbers like 9999, and that's the largest number it can go to, and it can also have decimals. And so what these are mainly used for are timers, right? And these are really useful if you want to have like a visible timer or some, countdown or something like that, right? And the other version, the more useful version of this, is the screen display, right? And so basically what this does is, I have some styrofoam here so these don't poke me, but you can connect this to your breadboard or using the female to male connectors, and have this as a display that shows whatever you want it to. You can display words, you can display numbers, you can display symbols, anything, right? And this is really useful because you're not just limited to numbers like the countdowns, like the 0 to 9 displays, right? And these are really useful as well. All right, our next part is a extender board, which basically, if you don't have enough space on your breadboard, you have the option to extend your board using these extra ports. And you also have 2 buttons here, which I will talk about in a second. And these are really useful when your project's overloaded and you need some space to create some more things or to simplify your project a bit more. All right, our next part is a set of different motors. So let's start with stepper motor. Oops, it's a little bit tangled. Give me a second. Perfect. All right, so here is our stepper motor. And basically this is a type of motor that can run in different segments, and it's really great. And this is the stepper motor controller, and basically this little chip on top gives different instructions to when you would just connect it into your breadboard. If you did that, your motor wouldn't work, so you need a specific controller to deliver specific instructions to it. And this would connect right here. You connect it, and then you could run it, and you also have an attachment for it, which is occupied at the moment by the next motor, which is a regular motor with 2 wires, which one is 5 volts, one is ground. All right, and or you could also connect this to a port, actually, the red one, and get some more variety in your motor. right? And so basically this is a motor. There's a fan which is bent because the kit was crushing the fan by accident, of course. And then this attachment goes into the stepper motor as well if you wanted it to, which is really awesome, really great. And basically this motor can spin at any speed, and it's really great for projects that require like a visual display of something that's happening, and you want to have some type of visual alarm to that. And then our third type of motor is not exactly a motor, it's called a servo. But what this does is it can rotate 180 degrees in any direction, right? So let's say this attachment, if I wanted to keep it right here, right? It could rotate 100 degrees this way, or it could rotate 100 degrees this way. And it cannot rotate all the way around. And so basically what this is useful for is it's really, really strong. It's really hard to turn, right? And this allows it to hit things really hard, or like have oscillating motion, right? And that's really important for some projects that require more fine tuning than a motor that spins forever, right? And so these are really useful for many projects that I'll be showing on this channel. This next part is a relay, which is basically a switch that goes from 0 to 1 and 1 to 0. So where 0 would be off and 1 would be on. And this is basically an inverter gate. It's really useful for when you're doing binary projects where, again, as I mentioned, 0 and 1 are really useful for on and off. And you can create specific gates like prediction algorithms and things like that, right? And this is for more advanced projects though, so I don't think I will be using it on this channel. Our next part is the IC receiver and the IC remote. So basically how these work is this is a sensor that plugs into your breadboard, or again, female to male connectors. And this remote, you have to point it at the sensor and you can press buttons. Now you do have to actually code this remote. Like it doesn't just work like, oh, I press a 6, it'll return a 6. You have to code it so that it'll return a 6. I could also, like let's say this is volume plus, I could code volume plus to be on a different number or something like that. This could be volume up, this could be volume down, right? So this all needs to be coded. It's not entirely visual. That's the only thing I don't like about this kit, is that this remote that it comes with is labeled, right? But other than that, it's really cool. And that's what the labeling is what misled me the first time I used it. All right, our next part is a temperature and humidity sensor, right? So what this does is you plug it into your breadboard or female to male connectors. You can put it somewhere, and if you have a reading attached to it, you can read the temperature in Celsius, Fahrenheit. It has settings for that, and it can also read the humidity value. Like in Florida, it's really high. In California, it's somewhat low. So yeah, things like that. It's really cool. We might be using it on this channel, but it is an interesting part to say the least. And our next part is fairly important for this as well. This is called a potentiometer. All right. So what this does is it spins, right? You can spin this dial. Make sure you don't spin it too far, otherwise you can break, which it does so really easily. And basically what this does, it has a range of values between 0 and 1024 and 1023. And basically what this does is it can hit all of those ranges of values, and this is really useful for projects like, say you want to dim an LED, right? So you could spin this and it would raise the voltage slowly, and that's really cool. That's really an exciting project. And also it's used kind of like a dial, really. If you didn't want to use the IC remote, you could use this as like a volume up type thing, and it's a really cool part to use. I'll be using it a lot, most likely. And then one of the most important parts here, the button. All right, I showed this on the extender board, but this is the physical singular version of it, where you plug it into your breadboard, you connect different things to these metal bits, and then you can press the button. All right, and what this is useful for is it returns values of 0 for off or 1 for on, and you can set it to do different things if it's 1 and different things if it's 0. And this allows for like memory. If you wanted, you could press the button, have it remember something, and then press the button again and remember something else, and you could run different projects with it. It's really, really cool. And then our next part is a special type of LED, an RGB LED. You can see this one has like 4 different wires. Like, that's really weird, right? But really it's fairly simple actually. So the longest wire is 5 volts right here. Sorry for the camera, but the longest wire is 5 volts. So you would connect that to 5 volts. And the next 3 wires connect to red, blue, and green. And if you know that red, blue, and green make all the colors of visible light, that's pretty good. Then you have a good basis in this. And basically these red, blue, and green values run from 0 to 255. And they cover all that range of values, and this LED can produce any color that humans can see, which is really cool. All right, so our next part is a photoresistor. And basically what this does is it can sense light intensity, and it can send a signal to your breadboard to do something, right? And it does this using a range of values, and it can measure whether something's dark, whether something's light, and whether something's colored enough to trigger a light change. And that's really cool. And I will probably be using that a bit on this channel. And so our next part will be an NPN transistor. And basically what it has 2 different purposes. It can be an amplifier, which is it can amplify your voltage or current based on what you need, and that's really cool because if you need extra voltage or current for your project and you're not getting it using like the battery or your laptop, you can use this and amplify it. And you can also have it be a switch, so it can go from 0 to 1 and 1 to 0, and you can switch like binary on your breadboard, and that's really cool as well. And our next part will be a tilt switch. So basically this little capsule has weights in it, and this can measure how much your project tilts. And so this is really useful for like robots and stuff, especially like robots on uneven terrain. So if you can measure if your like robot is going downwards, maybe slow down a little bit so it doesn't crash. And that's just an example, but these are really exciting tools and really great to work with. And then our next pair actually is 2 different types of buzzers. So this one is an active buzzer, and this one is a passive buzzer. What's different between these is the amounts of control that you have with your buzzer. So basically what these do is they create sound, and they work in different ways. So the passive buzzer has 2 different plates inside that buzz really, really fast, like nanosecond fast, and they create sound. And the active buzzer, you can lift this little part off, and then it becomes a passive buzzer, but you need to have this extra part on to make it an active buzzer, and it works a little bit differently. Right? And on this channel, what we'll be using is the passive buzzer. So the active buzzer isn't as useful for our purposes. And so our next part is the diode rectifier. And so basically, this diode rectifier can change alternating current to direct current and vice versa. All right, so AC to DC and DC to AC is really useful when you want to have different types of currents in your project. And well, I don't believe we will be using it on this channel, but it's a really cool part to have nonetheless. And our next part is a thermistor. Now this little tiny thing can measure temperature fluctuations, much like the humidity sensor, but it's much smaller and much easier to implement in your projects. It's more for heat changes rather than temperature changes, actually, so it can measure more precisely. And then these things are chips. So these extra chips are AND gates and OR gates. So this one is an AND gate. It has a different number on it. It's L293D. That's an AND gate. And basically what it does, it has different connections of AND. If you want another video on that, check out another channel about digital electronics. And so basically what this does is it's an AND gate. So if you put one input, you put another input, it'll multiply the two together to create a third input. And that's binary, right? So if you wanted to have like a 1 and a 1, you multiply this together, you get a 1, right? So your output would be high, 5 volts. So if you put 5 volts and 5 volts, you would get 5 volts. If you put 0 volts, 0 volts, you would get 0 volts. And so with this, you can go into Boolean logic and do some really cool things, really finicky things. But I believe for the purposes of this channel, we won't be using it. And this one is a motor controller, right? So this one, you have to plug in into your breadboard so that your motor can work, and it has specific controls for each of the ports to allow it to run the motor forwards, run the motor backwards, and stop the motor and do different things based on the motor's behavior. And so you need this to work your motor, specifically this motor, the one with the fan. Otherwise, your motor will not work. And all right, that was every single part in the Super Starter Kit Uno R3 project. If you haven't already gotten this kit, I recommend getting it. After seeing all of these parts, you can create some really cool stuff. And in the next video, I'll be showing you how to work a small circuit of LEDs and resistors. Thank you so much. Bye-bye.